Today we're going to talk about function composition. Function composition is essentially using one function as the input for another function. So, if f and g are functions, then notice my symbol for composing functions is a small little circle. It has an open in the middle, a little donut shape to it. It's not a dot, and it does not mean times. It means function composition. So f composed with g of x is equal to f of g of x. So let's have some examples. If f of x equals x squared plus 1 and g of x is equal to 3x plus 5, so I've got two different functions, then f composed with g of x, well, that's f of g of x, and that is f of g of x is 3x plus 5. Now I rewrite f of x, putting an empty set of parentheses everywhere the x is. I know that I'm going to put something kind of big in there, so I'm going to leave myself some room. And then I'm going to emphasize this in a different color. That is f of x. G of x is the input to f of x. And I can expand that. That's going to be 9x squared plus 30x plus 25. Then I have this plus 1 from the outside here. And remember that exponents do not distribute. If you don't remember the formula for squaring something, although you should, if you don't remember it, you can do 3x plus 5 times 3x plus 5. You will find that it comes out to be exactly this. I do have a little bit of simplifying to do. I can combine like terms here, and that will get me 9x squared plus 30x plus 26. Now, I want to use the same functions. Actually, I'll use the same piece of paper. I'm going to draw a line here. I'm going to use the same functions, and instead of doing f composed with g of x, I will do g composed with f of x. So this is going to be g of f of x. That's going to be g of f of x is x squared plus 1. So I'm going to rewrite g with an empty set of parentheses everywhere there's an x. So g parentheses plus 5. X squared plus 1 is my input. So that's my function that gets input into my other function. Now this time the simplifying to do is a little bit simpler. I can just distribute. I get 3x squared plus 3 plus 5. So I can combine like terms and get 3x squared plus 8. And I'm going to write this in pink here. Notice that in general, F composed with G is not equal to G composed with F. I got two different things. There will be special circumstances where they are equal, but in general they're not. You definitely cannot assume that they will always give you the same thing. They very rarely give you the same thing. Okay, now we're going to talk about the domains of composite functions. So the domain x. So the domain of G composed with F is the set of all values x in the domain of F, so that f of x, referring to that x right there, is in the domain of G. So let's have an example. Suppose I've got f of x equals the square root of x plus 2, and g of x equals negative 1 over x. The first thing that I need to consider is the domain of the innermost function. So remember, g composed with f of x is equal to g of f of x. So I really want to think of this from the inside out. So the domain of f is, so let's say, notice that we're going to use our usual notation of capital D subscript f for the domain of f. That is the interval from -2 to infinity. And I want to make sure that that doesn't make any problems when we put this into G. So f of x is the square root of x plus 2. I want to make sure we don't introduce any new restrictions. So find the domain of G composed with f of x equals, well, I need to put this in where the x is. So now notice that my radicand is the same as it was before. This will cover any problems from the radicand being negative, or there will be no problems in this interval from the radicand being negative. But I do have a fraction now where I didn't before. So I do want to make sure to think about what could cause this denominator to be 0. And the answer to that is found by setting, let's see, to find what would make the denominator 0. So we're going to set the denominator equal to 0. I can square both sides. And so -2 is not in the domain of G composed with f. So the domain of G composed with f is almost exactly the same as the domain of f, but I have to throw away -2. Fortunately, -2 is an endpoint, so that makes it easy. I just go from a closed bracket where I included it to an open bracket where I do not include it. And there is my domain.